All right, the third topic we're going to review is density and temperature. All of this should be very familiar. This was done both in regular and honors, so there shouldn't be any surprises with these two. You will not be asked to know the conversion between Celsius and Fahrenheit. You do need to know the conversion between Celsius and Kelvin. You also need to know your density equation. So density, as you've been hearing about forever and ever, is just the amount of matter you have in a certain volume of that substance. It's always going to be a ratio. You can use volume, or you can measure volume by dimensions with the length, width, and height using your various geometric formulas depending on the shape. Or if it's a liquid, you can measure it with a graduated cylinder. You can also do it with gases that can be displaced, that can displace water. We'll talk about that a little bit later. So depending on your units, you may have to do some conversions like we did in the dimensional analysis topic. It is a physical property. It is a way we can identify substances. Those with bigger densities will sink below substances that have smaller densities, and those with smaller densities will actually float. And so density, again, is just a ratio of mass over volume. Those of you who have had me before have definitely seen this triangle. I believe Mr. Copenhaver uses it as well. DC, Maryland, Virginia, Department of Motor Vehicles. Basically hide the variable that you're looking for, and that tells you how to rearrange your density equation in terms of the other variables. So density is mass over volume. Volume is mass over density. And then when you hide mass, density and volume are in the same row together, so it is density times volume. Temperature represents the random motions of a molecule. We can measure temperature with thermometers or with temperature sensors that are attached to those LabQuest units. And temperature changes can help us determine quantities of energy that are absorbed or released. They allow us to determine the change in energy, because you can't measure energy, but because of temperature and the fact that we have equations that relate temperature to energy, we can use that to help us determine how much energy has been changed. Units of energy are both joules and calories. Your kinetic energy, the energy of motion, is directly related to your Kelvin temperature. Sorry, Snow decided to come in and say hi. The higher the temperature, the more kinetic energy you have. Celsius to Kelvin, I told you, is an equation you will need to know. Celsius plus 273.15 equals Kelvin. I am totally fine if you use 273, but that is not an equation I will give you. That is one you need to know. So the first example we're going to do is really straightforward. Iron has a density of 7.87 grams per cubic centimeter. If the volume of iron is 75 milliliters, what is its mass in grams? So using our density equation to find mass, we multiply density times volume. We were given a density in the first sentence. We were given a volume in the second sentence. Centimeters cubed and milliliters are different units, but if you recollect from our dimensional analysis review, a centimeter cubed is equal to a milliliter, and so because of that, those units do cancel out, and then we are left with grams. Those both would affect sig figs. Since both numbers have 3 sig figs, we want 3 in our answer. So we would keep 590 with a decimal to represent that 0 as being significant grams. Our second example is going to involve using water displacement, which we can use to determine the volume of a solid that does not have regular dimensions. So pellets are a good example. We have iron pellets here with their density, 7.87 grams per cubic centimeter. They were added to a graduated cylinder that initially had 12.7 mils of water. And when the iron pellets were placed in the cylinder, they caused the water level to go up to 21.6 mils. And then we want to know what the mass of this metal is as well. To find the mass of this metal, we need both its density and its volume. So to get the volume for the iron, we need to take the water away. The second volume that we reported, 21.6, was the combined volume of the water and the iron. So when I take the difference between those two, I get a volume of 8.9. I do only want to show 2 sig figs in that calculation because we're subtracting. So we want to look at decimal places, and both measurements had 1 decimal place. So to find the mass of my metal, I take the density of it, 7.87. I multiply it by its volume. Again, centimeters cubed and milliliters are equivalent. I want 2 sig figs in my answer this time because of that volume, and so I would round my answer off to 70 with the decimal grams. All right, and so we're just going to do one quick temperature example. Average temperature in school is 25.0 degrees Celsius. What is this temperature in Kelvin? So to go from Celsius to Kelvin, I always remember these that C is the third letter, K is the 11th, so you need to add to get from C to K. So 25.0 plus 273.15. 25.0 has one decimal place, which is why I want to round my answer off to 298.2. If you had left it at 273, you're going to keep the number of decimal places that are in this original temperature because this is the measured quantity. So your answer would have been 298. Okay? And I think that should get you through part 3 of the review.